Hello students, myself Sarama Malik Das, Assistant Professor of Gargi Memorial Institute of Technology. My today's lecture is about large sample test of significance and which is about test of single standard deviation. In my previous lecture, I discussed about the test of single proportion and something about that. So today I discuss about test of single standard deviation. Now let a random sample x1 x2 up to xn be taken from a population with mean mu to test the null hypothesis is 0 where sigma is equals to sigma 0 against an alternative right-sided hypothesis H1 at alpha level of significance. Then the best shear, that is best critical region, determined by the test statistics where is x square is equals to summation of I is equals to 1 to n xi minus mu whole square by sigma 0 square, which is given by x square greater than x alpha square when population mean mu is known and where alpha is the area under x square. This x square is defined as a chi-square x square curve with n degrees of freedom between the ordinates x alpha cube and x square is equals to infinity. So which is shown in the x alpha square, this is which is shown in the following figure. This now number 2 is x square is equals to summation of I is equals to 1 to n xi minus x bar whole square by sigma 0 square, which is equal to n into capital S square by sigma 0 square, where S is the sample standard deviation and is given by x square greater than x alpha square, and population mean is unknown. When population mean is unknown, in the first case population mean is known, and here the population mean mu is unknown, and alpha is the area under chi-square curve with n minus 1 degree of freedom. N minus degree of freedom between the ordinates alpha x alpha square and x square is equals to infinity, which is also shown in the above figure. Okay, so for example, let a sample 4, 5, 6 up to 32, 33 of size 30 is drawn from a population with mean 4. It is assumed that the standard deviation of the population is 3. Test this assumption is assumption at 0.1% level of significance. And here given chi-square of 0.001, that is equals to 59.703 with 30 degree of freedom, and chi-square 0.001 is equals to 58.302 with 29 degree of freedom. It is given. Okay, so as here population mean is equals to 4, which is mu is equals to 4, and population standard deviation, that is sigma. The null hypothesis is 0, that is sigma is equals to 3, and we take alternative hypothesis H1 where mu greater than 3. Okay, as it is a right sided alternative hypothesis, so it is mu greater than 3. Then we have to find out the test statistics. The test statistics x square is equals to, here mu is known, so it is 1 by sigma square, into summation of I is equals to 1 to 40 xi minus mu whole square, that is equals to 1 by 3 square into 4 minus 3 whole square plus 5 minus 3 whole square plus dot 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 up to 33 minus 3 whole square. Okay, so this is can be written as 1 by 3 square into 1 square plus 2 square plus 3 square plus dot 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 up to 30 square. Okay, so that means it is 1 by 9, and this value is 30 into 30 plus 1 into 2 into 30 plus 1 by 6. Okay, so this value is 1050.56 with 30 degree of freedom. Okay, and alpha is equals to 0.1 by 100, that is 0.001. And it is given that chi-square of 0.001, this is equals to 59.703 with 30 degree of freedom. And so the critical region is, so the CR is chi-square greater than 59.703 at 0.1% level of significance. And come here, the computed value x square is equals to 1050.56, which is greater than 59.703. So 80 is fall into the CR, that means 80 is rejected. So we conclude that the population standard deviation cannot be 3. Okay, now we see another example. A random sample of size 31 from a normal population gives a sample mean (42) and a sample standard deviation of 5. Test at 5% level of significance. That the population SD is 7, and it is given chi-square at 0.05 is equals to 43.77 and chi-square as 0.05 is equals to 42.557 with 30 and 29 degrees of freedom respectively. its value is given. Okay, so here see here that population mean is unknown here. Okay, and number of sample, that is n is equals to 31, 80, which is null hypothesis, is equals to mu is equals to 7. Okay, as the population mean is unknown here, so the test statistic chi-square is equals to n into a square by sigma square, that is equals to 31 into 5 square by 7 square, which is 15.82, with n minus 1, that is 30 degree of freedom. And alpha is equals to 5 by 100, that is 0.05, and it is given, that is chi-square 0.05, which is equals to 43.77 at 30 degree of freedom. So CR is chi-square greater than 43.77 at 5% level of significance. Okay, and the computed value chi-square is equals to 15.82, which is not greater than 43.77. That means it's not fall in the critical region, it's fall in the region acceptance. Okay, so this value does not fall in CR, that means 80 is accepted at 5% level. So we conclude that the population SD may be 7. Okay, next day we discuss about difference of mean, that means test of equality of means. Okay.